All right, 5.7, systems of linear inequalities. Okay, now we're working with more than one inequality. All right, example 1, pretty easy stuff. We have to determine if the ordered pair is a solution. So I have to see if this point works for both inequalities. I plug it into the first, and I get 5 is less than 6. Well, that's true. That works. How about for the second? It has to work for both. So I have 5 is greater than or equal to 3 plus 1. So I get 5 is greater than or equal to 4. Well, that's true. So the answer for part A is yes. It is a solution to the system of inequalities. All right, how about for B? Let's plug in the information, x and y. I get 0 is less than 2 times negative 2. So I have 0 is less than negative 4. That is not true. So right away your answer is no. It just has to not work for one of the inequalities, and it's not a solution then. All right, let's go on to example 2. Graphing a system of linear inequalities. All right, so in the last lesson we graphed one inequality at a time. In this lesson we're graphing 2. So when you graph, what you're concerned about is where the shaded regions overlap, and that represents your solution to the system. So let's do an example. Graphing a system. Okay, we have graph the system of linear equations. We already have it in slope-intercept form. Wonderful. So I have y is less than or equal to 3. Let's see, I got 3 up here. All the y values are 3. All the y values are 3. Okay, and it says less than or equal to, so I'm going to use a solid line. And it's less than, so I shade below. Shading below. All right, let's go on to the second equation. Slope is 1 over 1. I start at 2. I go up 1, right 2, up 1, right 2, down 1, back 2. All right, and it's greater than. All right, nothing about equals. All right, so it's a dashed line then, because there's no equal sign. And I'm going to shade above. Okay, and I shade above. And where do these shaded regions overlap? Right here. So this is what you want to emphasize in your solution, because that's the solution. All right, so I want to make it very apparent. All right, this green area represents your solution. I could pick any point from this green area, plug it into these inequalities, and it's going to work out to be true. All right, let's do another example. All right, first thing we have to do is get it in slope-intercept form. So I'm just going to rewrite the equation down here. Write out the work. Subtract 2x. I have y is less than negative 2x minus 1. All right, that's for the first equation. How about for the second? Subtract 2x. So I have what? Y is greater than negative 2x plus 3. All right, so I'm going to graph these now. I have minus 1, we'll go down 1, and then I'm going to go negative 2 over 1 for the slope. Negative 2 over 1. Up 2, back 1, up 2, back 1, up 2, back 1, up 2, back 1. All right, it's less than, so it's just a dashed line. And shading below. Then I go up 3, and I go down to right 1. All right, it's greater than, no equal sign, so it's a dashed line. And it's greater than, so I'm shading above the graph. All right, just imagine it's a hill, and the sky is above, the ground is below. All right, and then shade in where the shaded regions overlap. They don't overlap. So since they don't overlap, your answer is there's no solution. All right. And another example here. Write a system of linear inequalities represented by the graph. Okay, so this really pushes your understanding of this concept. Let's see, I have a line here at y equals 2. All the y values are 2. So, okay, and the shaded region is above, so it must be greater than. The line is also solid, all right? So there must be an equal sign. And so I have y is greater than or equal to 2. Or it should be negative 2, all right? All the y values are negative 2. All right, and then for the other equation or inequality, I have y is, well, we're shading below. I'll use a different color. We're shading below this line, so it's going to be less than, and it's dashed, so there's no equal sign. And let's figure out what the slope is. Well, the y-intercept is 0, all right? There's no y-intercept. And what's the slope? So starting from here, I go down 1, and I go left 1. So it's negative 1 over 1, which is 1. Or we could also go up 1, right 1, which is 1 over 1. So it's 1x, or just x. All right, so once again, just so you don't get confused by that, I'm going up 1, right 1, that's 1. So I could have a 1 here if I wanted to. And then we're starting at the y-intercept, which is 0. So I could also put plus 0 there. But as your final answer, you want to keep it nice and clean. This is what you would write. All right, that's your final solution. All right, and the last example. All right, write a system of linear inequalities represented by the graph. Okay, once again. All right, here we have vertical line. All right, and what are all the x values? They're all 3. So x is something to 3. All right, it's going to be less than, because we're shaded on the left side over here. And it's equal to, because the line is solid. All right, so we have the vertical line. Now for the dashed line, okay, let's see. Here's my y-intercept. That's 1. And then I'm shading above, right, that line, so it's going to be greater than. And the line is dashed, so there's no equal sign. What's the slope? I'm going to go up 2, and I'm going to go right 3. All right, so it's up to right 3. All right, then x plus 1. We don't really have to polish anything up here, so that's it. There's our system of inequalities to describe this graph that we're looking at. And that's it for the chapter. If you have any questions, make sure to ask. Begin the assignment at the bottom of the webpage.